Hello, and today we're going to learn how to convert angle measurements between degrees, radians, and rotations. So first of all, we need a statement of equality between all three of them. There's two of them up here. So pi radians, and usually you don't see the word radians, but pi radians is equal to 180 degrees, which is also equal to 1/2 of a rotation. Also, if you multiplied every single one of these by 2, you'd still get a statement of equality. 2 pi radians is equal to 360 degrees, which is equal to 1 rotation. You can actually set up your own statement of equality if you wanted to. Pi over 2 radians is equal to 90 degrees, is equal to 1/4 of a rotation. I mean, it doesn't matter what you use, but you need to understand the initial conversion. This might be easier to know initially. This might be easier numerically when you start converting. But what we're going to basically do is, using these statements of equality, we're going to multiply a given angle value by a fraction, which is equivalent to 1, but that will reduce out the units we're given and replace a unit that we're looking for. And I'll show you what I mean right now. So we're trying to convert this into degrees. This looks like in terms of radians. Usually when you see a pi involved in an angle measurement, it's radians. It's implied that it's radians. So how are we going to convert this? Well, we need to set up some sort of fraction, right? And because we need the radians to reduce, we're going to need to put the radians in the denominator. So pi radians. And we need to put its equivalent in the numerator. We're trying to convert to degrees, so its equivalent is 180 degrees. Now what will happen, you'll see, is that the pi in the denominator is going to reduce with the pi in the numerator over there. And we have 3 times 180 divided by 2, and this is all degrees. Now you could do this in any order if you want. I'm going to divide 180 by 2 to get 90, and then 90 times 3 is really 9 times 3 times 10, which is 270. So 270 degrees. Again, notice that because I was given radians as a measurement, I started off with radians in the denominator so that the units would reduce, and then in the numerator I replaced it with its equivalent, and the equivalent of pi radians is 180 degrees. Okay. Alright, let's convert 90 degrees to rotations. Alright, again, I need to start off with my denominator being degrees. In this case, I'm going to use the conversion of 360 degrees is equal to 1 rotation. So 360 degrees is going to go in the denominator, and what's going to happen is the unit of degree is going to reduce. Degree over degree is now unitless, but then it replaced with rotations. And again, notice that 1 rotation and 360 degrees are equivalent, so really I'm multiplying this by 1. The value of 1 rotation divided by 360 degrees is 1. So I'm going to have 90 in the numerator and then 360 in the denominator. And 90 divided by 360, well, you can reduce the fraction. 90 goes into 90 once, 90 goes into 364 times. So this is 1/4 of a rotation, which, I think makes sense because my guess is you can do this conversion pretty quickly. 90 degrees is 1/4 of the way through your unit circle, so it's 1/4 of a rotation. Alrighty. Alright, let's do one that's a little bit more difficult. So convert 1.8 rotations into degrees. To do that, again, we need to replace the rotations, the rotation unit with degrees. So we're going to start off with rotations in the denominator. The conversion between rotation and degrees is that 1 rotation is equal to 360 degrees. So notice that the rotation units reduce, and now it's replaced by a degree sign. So we can rewrite this as 1.8 times 360 degrees. All over 1, but anything divided by 1 is just itself. And if we do this multiplication problem out, we get that is 648 degrees. Okay. So that's the equivalent of that angle in degrees. One more. Let's convert 270 degrees into radians. So again, we're trying to reduce out the degrees, so that's what's going to go in the denominator. For this one, I'm going to do 180 degrees, and that's equal to pi radians. So the degree unit will reduce, so I really have 270 pi divided by 180. 90 goes into both 270 and 180 evenly, so 90 goes into 273 times. And 90 goes into 180 twice. So this is your radian equivalent of 270 degrees, which we actually already knew because the very first problem we did, we were converting this into this. So it makes sense that it would work in reverse the same way. All right, so that is the basics of how you convert any angle measurement into another unit.